All right, so I'm going to do something a little bit different for this chapter. Rather than narrate the slides, instead I'm going to walk you through an example like you'll have on the tests and assignments so that you can see exactly what you should be able to do. Okay, so this is one of the examples from your book, and I encourage you to go through and do the rest. This is a cognitive study looking at reaction time. Reaction time is the dependent variable. I know that it's the dependent variable because it's on the x-axis. So the dependent variable always goes on the x-axis. And so this is looking at reaction time, how reaction time is influenced by delay in seconds. So is there a 30-second delay versus a 60-second delay? And also how it's influenced by pattern complexity. So is it a simple pattern versus a complex pattern? So again, with complex designs, if you haven't already read the chapter, make sure you go back and do that first. But with complex designs, we're talking about designs that have two or more independent variables, although all our examples will be two. So we've been looking at the data mostly in tables, but I have all of the information in this graph that I need to create a table. Remember that each of these dots indicates a mean for each group. So this dot, let's do one up here. This dot right here would be the mean for individuals in the complex pattern with a 60-second delay. This dot right here indicates the mean for the group that had a simple pattern with a 60-second delay. So we know our two independent variables and we know the levels of each, so I can set up a table just like we've been discussing. We've got pattern complexity, either simple or complex. So pattern complexity is the first independent variable, levels are simple and complex. Delay is the second independent variable and the levels are 30 seconds versus 60 seconds. So now, and we have all our means, so all I need to do is transfer that information. So this dot right here represents simple pattern complexity with a 30-second delay. When you're going from a line graph, you have to kind of estimate, but you'll get close enough. So this looks like maybe 525. Simple with a 67-second delay looks like about 575. So still on the simple line, but the longer delay. Complex pattern with a 30-second delay is about 550, and complex pattern with a 60-second delay looks about 750s. So most of the examples I won't give you will not start out as a line graph. Instead, you'll have the data in the table and you'll need to convert it to a line graph. So you just do the opposite. Do it the same way, just going in the reverse. Determine which independent variable will be on the graph and which will be represented by a different line. I'd start by doing the one that's a line. So if you wanted to graph the simple pattern complexity, you draw a dot for your mean for the 30-second pattern and for the 60-second pattern and then connect them. And then you do the same for the complex line. Now, of course, your dependent variable will always be on the y-axis. Okay, so first thing we want to test for is the main effect of each independent variable. So we're going to start with pattern complexity. Okay, so we want to think about if we want to test the main effect of pattern complexity, which groups am I interested in? So if we're testing pattern complexity, we are looking at the difference between the simple group versus the complex group. So we want to look across. Okay, so we're looking at, regardless of delay, what's the difference between the simple and complex group? So because we're averaging across delay, we're going to go down, right? We don't care about delay. We just want to know the average for simple versus complex. So the average for 30 and 60 seconds is 550 for simple, 650 for complex. Okay, so it looks like there is a main effect. The complex pattern group have a slower reaction time than the simple pattern group. So reaction times are sometimes confusing. A longer one is bad, right? So the complex pattern took longer to respond compared to the simple pattern. When you're interpreting any kind of main effects or interactions, make sure that you go back to the dependent variable, right? In this case, it's reaction time. So you want to make sure you talk about that. Just calculating the averages, the means, is not enough. You need to interpret them as well. So you would say, regardless of delay, the complex group had a longer reaction time, our dependent variable, than the simple group. Okay, next, I want to know about the main effect of delay. So if I want to know about the main effect of delay, I want to know the difference between the 30-second group versus the 60-second group. So I'm going to average across this time. All right. And so I get my numbers here. And it looks like there's a main effect of delay as well. And it looks like the 60-second delay takes longer than the 30-second delay, or leads to slower reaction times. So again, be sure that I'm going to be sure that I include my dependent variable in my interpretation. And I'm going to say something like, regardless of complexity, the 60-second group had a longer reaction time than the 30-second group. So that's my interpretation. I've done my calculations and I've also interpreted it. So next we're going to move on to interactions. And so the question with an interaction is, do the effects of delay differ depending on the level of pattern complexity? So with an interaction, you're asking, do the effects of one variable, one independent variable, differ depending on the levels of the second? If you didn't already have a graph, I tell you it's nice to start by graphing this. And if we think back to the graph, we remember the lines weren't parallel, so we suspect there might be an interaction. And we can always also test for an interaction using the subtraction method. When you're doing the subtraction method, you can go either way. Okay, so when you're getting the means for main effects, it matters, right? Because you want to get the means for 30 seconds and 60 seconds or the other way around. When you're testing for an interaction, all you want to know is there a difference? So in this case, I went down. You could also go across. The specific numbers don't matter. What we're looking for with the subtraction method is whether there's a difference between, for example, 30 versus 60. Is the difference the same at the different levels of pattern complexity? This is a pretty substantial difference, which suggests that we do have an interaction. So if these numbers, these differences were the same, we would conclude that there was no interaction. Okay, so with the subtraction method, you're asking, is there an interaction effect? If the numbers come out different, you conclude there is an interaction effect. So we need to go back to our graph to interpret the interaction effect. Where is the difference? So this is just kind of reminding you that each number in your table is a point on the graph. Remember that your dependent variable always goes on the y-axis, and one independent variable, and it's really arbitrary which one you choose, goes on the x-axis. The other is indicated by a solid or dotted line. So because the lines are not parallel, remember that even though they don't actually cross in the figure, if they will at some point in time, they're not parallel. So this supports the findings from the subtraction method that there is an interaction. So now we need to figure out what's going on with that interaction. And the way we do that is our simple main effects. And so remember that these are different than the main effects. Simple main effects are a way at interpreting the interaction. So remember, we'll pick one of the independent variables to focus on and describe what's happening with the other independent variable at each level, our main one. So what does this look like? When you have a figure like this, you want to pick either one independent variable or the other. I think it's easier to pick the one on the y-axis than the lines. Okay, so let's do that. So we're going to describe what's happening at a 30-second delay, and then separately, in a separate sentence, describe what's happening at a 60-second delay. So at a 30-second delay, there is only a small difference in reaction time between simple and complex tasks. They're essentially the same. In contrast, so next I'm going to describe what's happening at a 60-second delay. At a 60-second delay, people have much longer reaction times to the complex than the simple patterns. So what this means is that the effect of pattern differs depending on the amount of delay people have in responding. Okay, so in order to fully interpret the interaction, you have to make sure you describe it at both levels of each independent variable. But this is essentially what you should be able to do with these problems. You need to convert from a line graph to a table and back. So you need to be able to go back and forth. You need to calculate and interpret the main effect, and you need to be able to explain them in terms of the independent and dependent variables being studied. You need to be able to use the subtraction method to know how to look for interactions. And then you need to be able to interpret an interaction by looking at the simple main effect.